Hi, Mike Matchett with Small World Big Data. Today we're here talking about multi-party computation, which is really how do we secure the privacy of data when we want to collaborate on it, when we want to monetize it, when we want to use it in conjunction with lots of other data sources. How do we, though, guarantee compliance and regulation data privacy? How do our other suppliers that we're working with for data do the same? How do we collaborate? How do we work together on that? Lots of things use this, like credit scoring, fraud detection, even just doing a better job for the end client down a whole supply chain of vendors. Stay tuned. We've got some answers for you. Hey, Jay Prakash, welcome to our show.
Hello. Thanks for having me.
All right, Jay, you're with Silence Laboratories, and what you generally work on is multi-party computation, which is a way for people to collaborate on data while holding the data itself private. Key to this is encryption and cryptography. It's kind of confusing at first for people to wrap their head around because it's something new. But before we dive into that, tell me a little bit about what got you excited about getting into the world of cryptography and data privacy. What motivated you to do that?
Right, yeah. So yeah, to answer that question, we can zoom out a bit and see the history of the company. So Silence Laboratories started as a university spin-out from Singapore. So my co-founder, we have been working on a couple of research, finding vulnerabilities in authentication systems. And yeah, that's led to the seed of Silence. In the beginning, we were an authentication company, and then yeah, we went to a couple of players and sell our authentication libraries. We believe that although we made some fascinating vulnerability discoveries, but they were not good enough for build a company. But in the process, we identified and we met with a couple of players in digital asset domain particularly, where a single point of failure of secrets was a paramount problem. And that led to a trigger where we latched onto a good problem to solve, and we had mathematical skill sets. So we all come from academia. All the four co-founders are PhDs in different domains of cybersecurity and do have math background. So yeah, we got a problem. Kind of found a very early hint of a PMF, and we started Silence to solve single point of failures for secrets. And then yeah, we keep on building on that, which probably yeah, maybe we'll talk more as we enter into a realm of privacy tech.
Okay, so as we get into this, let's just give everyone sort of a handle on what a potential use case might be for doing multi-party computation and preserving secrets. So there's an example that you started to give me earlier. Let's explore that a little bit more of where, say, credit scoring, right? I think where there is an agency, uh, and we all know their names, Equifax and whatever else, where
Mhm.
they're going to get data from many different sources and bring it to there. But if you bring all that data in the clear to there, they can become vulnerable to this, what you're calling single points of failure. In fact, I had a lot. I've got a letter here on my desk saying, they were breached. In fact, and like we
Okay.
get some credit scoring, right? So it is not just hypothetical that those companies can expose an awful lot of data. It has happened on there. Um, so what where now would you start to change that story if I was bringing in multi-party computation?
Yeah, sure. Credit scoring is a perfect example of data collaboration and avoiding any single point of failure. There are a couple of primitives before we understand how it works. Number one is user consent. Currently, we believe that user consent is not properly designed. It's misutilized a lot by financial institutions, be it for scoring or other purpose. Second one is rich data collaboration. So if you bring data in one place, the probability of getting multiple sources binded to that concept is hard. You can get data from five, four people or some group of companies. But if you want to create a much better score, it is proven in theory that if you get alternate sources of data, not from finance, from telecom and many other sources, then you can create much better score. That's where we come into picture. Our software stack and our infrastructure binds consent with computation, not with movement of data. So our motivation is to say, Let's give consent to compute something, not for replication or movement of data exactly. How it spin out is this. In the version which we are talking for scoring, all of these enterprises will have their on-premise or a dedicated cloud node where they will link the data pipeline. And our library will go and sit inside those nodes. And then it will trigger a distributed multi-party computation-based protocol, which essentially is a technique to compute a function f on distributed data with a guarantee that nobody sees each other's data. So now that function becomes a scoring function. All the enterprises, whether it's a telecom, bank, or any other data provider, they can be part of this ecosystem and spin out a distributed network. And in the end, they will all end up computing on their score with much higher accuracy, much better guarantees without looking at each other's data. So this is one of the sweet spot application of MPC or what we are building, and it can spin out into many other verticals where collaboration can be guaranteed without visibility of all data in one place. Again, single point of failure avoidance.
Yeah, so we start out by
And
saying
yeah.
yeah, yeah. So we start out
Mhm.
by talking about like security, like we don't want a single point of failure. Then we talk about compliance, saying it's really about making sure the end user's consent to being used is kept in-house, and so you don't share the data out. You control the
Mhm.
consent where the user gave consent. You don't share the data with partners who then don't track that properly. So we have some compliance issues, but we actually, social benefit is consent becomes tracked to the data more tightly. Uh,
Right.
and and we enable a kind of distributed computing, which sounds like it could lead to a lot of very effective ways of working with data. So we talk about credit
Mhm.
scoring. What are some other data collaborations you've seen people interested in?
Right. Yeah, we have been latching onto a multiple use dictionary of possible avenues. In finance sector itself, anti-money laundering requires collaboration across borders and among multiple institutions. That's a very good use case. Now you don't need to walk and convince multiple enterprises for cross-border data transfer. It won't take you months for moving data. Now you can do in a couple of seconds or minutes. That's one. The open banking ecosystem has been seeing lots of innovation lately, particularly in UK, even in South Asian countries like India. Open banking is getting quite mature. Open banking gives you opportunity to bind consent with some of the data providers. There, we can use a similar technique of distributed computation in a privacy manner for opening up lots of collaboration. People can use for designing better risks of the user when they are giving some predefined credit lines. That's one. In healthcare, we can use for collaboration among hospitals for finding better fit for certain medical trials. We can use it to predict or design better disease predictions based on certain symptoms or certain medical history, which can't be done currently because of privacy compliance and much regulatory avenues which kicks in and slows down the whole process. Medical is also a quite good avenue. We can use for trading as well, for secret trading when you don't want to expose your prices until the trade happens. So yeah, there are multiple avenues there and therein as well. So yeah, wherever we need collaboration to improve accuracy, something like this as a sweet spot.
Right.
And let's say we don't have collaboration, but you have single point of data, single source of data. The data at rest is certainly encrypted. Data in motion is encrypted. Those problems are solved. But data in use is where exposure happens. So what we also do is we split data into parts and they are distributed among nodes. Let's say simple case can be we split data into three parts, not literally, but using multi-party computation. And now whenever some API call hits, these nodes will talk to each other and create output. So you are guaranteeing that the data in users is also secure as data at rest and in motion. That's another avenue as well.
That's an interesting perspective. Probably deserves its own big banner at places, right? I hear all day long about encryption for data at rest, encryption for data in flight, and I've almost never heard of anybody talking about, really solving or addressing privacy concerns where data that's actually being used and collaborated on between parties. So, looks like there's a lot there. So, this is pretty interesting. And I and in the, are you guys moving towards a place where uh, people just keep downloading libraries? Are you going to make better libraries? Are you starting to work with partners on offering different services? What's sort of the future vision for Silence Laboratories?
Right. So yeah, we have defined our roadmap and our moonshot problems, which we will target one by one. As of now, we are optimizing our library to support arbitrary functions, link any very easily programmable suit to a compiler which converts to a protocol. And our library is being optimized for the speed and scalability. That's current focus. But down the line, the ultimate vision of Silence is to create a distributed networks which has multiple subnets for applications. One subnet for banks, one subnet for healthcare. If I have a good amount of resource and a good amount of time and a team, which we certainly have even now, we would like to create a global privacy preserving internet, define the complete architecture of privacy preserving internet, and design a platform where enterprises can just come, link up their data pipeline, and start to write collaboration codes. All the deployment, all the executions in a privacy preserving manner will be handled by us as a platform. So that's what we're aiming towards, create a collaboration platform with distributed nets. But that will take some time. Slowly we will reach. Right now we are looking for very strong early champions who can work together with us, solve some of these problems, maybe for scoring or healthcare or other sectors. And we'll use those cases to scale globally.
Yeah. I mean, it sounds like if you are successful in creating a global privacy preserving internet, to use your words, that could quickly be something that standards bodies and compliance bodies and regulation agencies would say that's what our members need to do. So it could be something that snowballs a little bit fast if you can get there, because what's out there today doesn't offer much in the way of privacy. Once the data is shared, it's gone on there. And you're right. There's definitely a problem or opportunities to be had with collaboration on data while preserving the privacy on it. So very good, Jay. This is just fascinating, and I'm just curious to follow what's going on and stay in touch with you guys. So maybe we'll have you back when you get to some more milestones here. But if someone today is interested in and heard something here that really piques their interest on Silence Laboratories or on your libraries, Silent Shard, Silent Assist, and I'm sorry, Silent Asset, and some other things that are available. Where should they start? Where would you recommend they start their educational journey into what you're doing with
Right.
multi-party
On our website,
computation?
Silence Laboratories, yeah, on our website, silencelaboratories.com, we have a product suite which talks about Silent Shard for digital asset, Silent Compute for general computation. That gives an early hint of what we are trying to build. But on the same page, you have book a call link. Anybody can book a call. I will jump on with our cryptographers and our engineers. We'll love to talk and brainstorm and figure out the problem which the enterprises are trying to solve. So
All
we'll
right.
work closely with them.
Yeah, it sounds like there's incredible opportunity here for this kind of solution. So wish you the best. Folks, check it out if you have issues like this and you want to explore what could be available. Take a look at Silence Laboratories. Thanks, Jay.
Thank you very much. Thank you.
Thanks.